Okay, now let me switch off mobile and let us see.
So good morning everyone. Welcome to session 2 of day 2 of the FDP on emerging trends in sustainable technology, sponsored by AICT New Delhi and organized by Mangalore Institute of Technology and Engineering, Moodabidri. I am Dr. Vignesh Nayakullal and I am the coordinator of this session. Participants are requested to kindly mute their audio while the session speaker delivers his talk. Our distinguished speaker for this session is Professor Arunachala Umesh Chandavar. On behalf of the Mechanical Department at Mangalore Institute of Technology and Engineering, I welcome you, sir.
Thank
Let
you.
me give a brief about Professor Chandavar. Professor Arunachala Umesh Chandavar is an senior associate professor in Mechanical Engineering Department at Manipal Institute of Technology. Professor Chandavar is engaged in solar thermal engineering. He is also a senior tutor in heat transfer, design of heat exchanger, and solar thermal energy field. Professor Arunachala Chandavar had earned his PhD in solar thermal engineering, and his thesis title was Study on Formation of Scale and its Effect on Performance of Solar Plate Collectors. Professor Chandavar has approximately 23 years of teaching experience, and his academic career began in the year of 1997 as a lecturer in mechanical engineering. From there on, he progressed to become an assistant professor in the year 2001. Thereon, he he became associate professor in the year 2011, and at present he is a senior associate professor in mechanical engineering department at MIT. Professor has supervised 19 master's students in their project work and is at present supervising 3 research scholars in their pursuit of doctoral degree. And Professor Chandavar has extensive uh, experience in the field of thermal engineering and has dealt with solar thermal energy systems and various other aspects of thermal engineering, such as fluid mechanics, uh, thermodynamics, etc. So, with that introduction, I invite Professor Chandavar to deliver his talk. Over to you, sir.
Yeah, thanks, Dr. Nayak, for a nice introduction. Am I audible to all?
Yes, sir, you are audible.
Okay, and how about my slides? Yeah, in full screen. Is it visible?
Yes, sir, presentation is visible.
Okay. Good morning to all. Let me start with the lecture, and I titled it as Advances uh, in Solar Energy Realization Techniques. So, and next approximately 1.5 hours, I'm going to cover, I'm going to brief about the solar energy. Then, as you know, there are 2 routes to harness solar energy: thermal route Just let me try to get pointer option. Yeah, yes, thermal route, then photovoltaic route, and I came to know that many participants from other stream than mechanical also engaged in this FDP. Uh, Particularly for mechanical based stream, at the end, even it's some kind of interdisciplinary research topics. What if you are a doctor, you can suggest this to your students, or if you are yet to pursue doctoral program, you can think about this project. It's just what I observed that I will highlight, and what kind of projects at present we're doing in our lab and facilities available. So it's just I'm not some kind of the advertisement team head, not like that. It's just to tell you what kind of facilities we have and how such facilities will be useful in doing the solar related projects. With only that aim, I am highlighting the last part. Okay, now these are some basic information all of us know that whatever the energy available to us is in one or the other form, direct or indirect form, it is from sun, and we are very much impressed with that kind of energy because it's clean, freely available, and that too abundantly, and the source can be predicted, and over most of the days over the year, at least 250 to 300 days per year, it is available, particularly in our country and most of the states, and that we can slowly get rid of the conventional fuel prices or the whatever the impact it does on environment by the use of solar energy. And as you know, so it is having the best modularity and scalability pattern in its use. So these are some energy statistics. So if you can look at 2050 onwards, so there's a huge gap. The world energy experts, they are predicting the photovoltaic and solar thermal power plants going to fill up this gap, as I mentioned here. That means we have a huge potential for such energy sources in future. This is a nice quote by Thomas Alva Edison. I'd put my money on the sun and solar energy. What a source of power. This what he claimed or he quoted during the last century itself. So with that, we will come to know the importance or the how effective is the solar energy. Okay, now most of the time I will be discussing these two things, that is photovoltaic and thermal route. First, let me take, because I'm a hardcore thermal person, so let me give preference to solar thermal route. What I will do, let me cover this quickly because I'm not going in detail or in depth mechanical or thermal part. So I'm just, it's some kind of awareness program. Let me complete the thermal part first. We'll give 1 or 2 minutes break. So if you have any queries, you can ask. And if you have any queries, it's better to note down this slide number so it is easy to trace a particular slide. And then I will continue with the photovoltaic. Again, after that, let us break for 1 or 2 minutes for any queries. Then, as a third part, some the projects and the facilities, let me cover. So hope everything will be done by 12:45 or the max before 1 o'clock. So am I audible, no? And you are comfortable?
Yes, sir, you're audible.
Okay. Yeah. So now in thermal route, we have classified the system into three. That is low temperature, medium, and high temperature system. And there is no hard and fast rule to fix this temperature. So you may ask if the temperature is 101 or 105, will it come under first or second? Not like that. It is in general, we mention less than 100 degree Celsius. We'll put it as low. And under this category, normally non-concentrating. So this concentrating, non-concentrating, this theme should be very clear before I start the further discussion. So with some diagram, I will make you understand what's the difference in these two systems. Then medium, so 100 to 125, 140 temperature range, we are using non-concentrating, and later we'll switch over to concentrating type. And high temperature system, obviously, it is concentrating type. Now, for example, you look at these two water heaters, and nowadays in almost all homes, we can see these two, particularly this type, we call it as evacuated tube water heater because it is cheap, highly efficient than this, but this is reliable, costly. The solar water heater entered the market in this design, and slowly nowadays evacuated tube design really eating this one as far as market share is concerned. So we call this as non-concentrating type because whatever the solar radiation falling, it, say if this is 2 meter square area, so whatever the solar radiation striking or the receiving area is 2 meter square, and the same area has been used for absorbing the heat, because the fluid, when the fluid flows through that, it uses the entire 2 meter square area. So those two area, whatever the solar radiation aperture area as well as the absorbed area, both are same, that is 2 by 2. That's why we call it as a non-concentrating time. And the same concept holds good in evacuated tube also. So this is the meaning of non-concentrating. And when we mention concentration, so there is a difference, or I can say the absorber area is always less and aperture area is more. Aperture means the area where the solar radiation falls. So that ratio we can have 30, 50, 100, 1000. It's based on, even you can think of the magnifying glass. During our childhood time, we used to burn paper by using solar and that sunshine with the help of the magnifying glass. So if you change the gap between paper and the magnifying glass, so you can change the concentration level. So like that, we can, if we are at higher concentration level, we will really get very high temperature. Yes. Now, so this is because my research started almost 15, 20 years back with the solar flat plate collector at that time, because this was leading the market and it had a severe problem of scaling. Scaling means when the hard water is in contact with this hot this unit, so the formation of scale within the tube, because these tubes are really small, that is 10 to 12 mm. So over the time, maybe 6 months, 1 year, based on the hardness level, it's going to form scale, and that way it's going to block the surface. And how this scale formation is going to affect the performance, that was my study way back in 2005, 2000, that time. Still I am audible and PPT is visible, no?
Yes, sir. Yes,
Okay.
sir.
Yeah, yeah. So this is just, I'm not sure causing what I am published so far, because this is my first paper that is, I can say, the more reputed journal, that is ASME, because that time we didn't have that kind of tendency of publishing in the quality journals. Publication itself was enough that time, but still I could manage this ASME publication with this kind of contour. And later I made it this artificially formed the scaling, because I wanted to know how the scaling thickness affects the pressure and the thermal efficiency of solar water heater. And that also a couple of articles got published in ASME, then Taylor and Francis. So slowly, yeah, even this I tried with thermosiphon system, because you know that whatever the solar water heater, if I go back, this kind of heater we call it as a thermosiphon system. We don't have any pump to circulate water, whatever stored in the tank, to the this receiver unit. This is by thermosiphon effect, in the sense when you heat water, temperature increases, ultimately density decreases. So there is a gradient between hot and cold fluid, that's the water. So what happens, because of density difference, the lighter region, it floats, and relatively colder region enters the bottom portion of the collector. Like that, the circulation happens. So this is what we call it as a thermosiphon system. So for better temperature control, we can also use the forced system. If you attach pump, so we have more authority over the flow rate. But in thermosiphon system, based on the solar radiation and the available system, the flow rate manages. We call it as a balance between pressure drop and pressure gain. So in force system also I tried that, but it the scaling not really deteriorated the performance of the force system. That also I could manage in SME. Yes, so like that, the best non-concentrating type of solar thermal system is water heater, as you know. But we have other systems. Continuously, let me have watch over time. Yeah, okay. So solar distillation to purify the water. Purify means we are not going for any reverse osmosis, ultraviolet treatment, nothing like that. Whatever the impurities like salt content is there, so we can remove it, and so-called potable water is possible with the simple distillation process. That's we known as solar distillation. Then solar dryer. So now some research, it is more of CFD and more of academic interest or academic, research are going on with respect to solar dryer, where this is the unit where absorber plate, there's a black coated, absorb the solar radiation falling over that, and to minimize the loss, there is a glass cover situated over that, and this is the flow duct. So from here, the relatively cold air from the surrounding enters, it gets heated up, and then it is circulated in this chamber where you can dry fruits, vegetables, etc. And the humid hot air escapes. This is the once through basis, and we don't need any pump like that. This again thermosiphon system. So as I said, there are with the research student from other institutes, MITE, so we have one publication in that where we are changing the absorber surface, or we call it as absorber surface treatment. So, and even we have solar absorption and solar vapor absorption, vapor compression system. Also, we can attach to solar system. See, you can. This is a solar absorption system. It's a thermal collector, and this is also vapor absorption. Sorry, vapor compression system, where directly the compressor is powered by the photovoltaic panel. So these are some. This is more of products than any real research into that. And after solar water heater, so the next the catchy item is solar cooker. As you know, there are a lot of designs available, all the way from box, the cheapest, within 1,000 rupees you will get this, and kind of this paraboloid, It may cost 3 to 5,000 rupees. And just to enhance the performance of a box cooker, you can have additional reflectors. Now, uh, yes, see now till previous slide I was telling only about non-concentrating system. Now the concentration ratio matters here. Now let me discuss this part later. You look at the paraboloid, this collector or dish. So this is the aperture area what we call. So say 5 by 4, whatever the diameter of the square. If this is 1 meter square and you see this guy is placing the pan hardly maybe 0.1 meter square, even not that much. Okay, say 0.05 meter square. The surface area pan is located at the focal point. So this focal point where the solar radiation, whatever it strikes the reflector, this is highly reflective surface, it strikes this bottom portion of the pan, and so whatever the food you want to cook can be done. So this is called as concentrating. Why I said concentrating? Because we are getting the ratio. If this is 1 meter and this 1 meter is finally focused to 0.05, that 0.05 by 1, sorry, 1 by 0.05 if you do, so you will end up with some 50 or sometime 100 or 25, 20 like that. CR, we call it as a concentration ratio, that changes. If this is same as this area, then we call it as a non-concentrating. Look at this box cooker. So how on which area the solar radiation is falling is say 1 meter square. But at the same time, how much is absorbed by the this whatever the absorbed plate, that is also 1 meter square. So that's why we call it as non-concentrating. So this is slightly towards concentrating because we have some additional surface aperture area is this plus this area also. So it may be 2 meter square and this may be 1 meter square, like that. Concentration ratio may be 2. So like that the concept of concentration ratio starts. And as the concentration increases, you can cook food quickly. And in our lab, we are we tried, or it's the regular experiment for our students, this box, but we are not really cooking any food because as far as BIS, the testing standard, we have to keep a known quantity of water, which is at atmospheric temperature, and we should check how much time it takes to reach the boiling point. So we get 90, 92, 93 degree in about 45 minutes to 1 hour in this. And remember, some of you can claim that by simply by keeping maybe 10 ml or 100 ml water, and you may claim that within 10 minutes I got the boiling point, and mine is the best. This one, collector or the cooker. It doesn't mean that. So per meter square, they have a rating. You have to keep that much quantity of water itself, and this link that quantity of water is linked to the area of the box cooker. But the same quantity we tried in this, and this hardly 20-25 minutes. So if we directly keep a cooker, so that whistle will come within 15-20 minutes if it is exposed to good sunshine. So that is the magic of solar radiation, or how the energy conversion takes place. So recently we just reviewed a lot of solar cookers. There are n number of designs available all the way from, because in this publication we quoted with 50 rupees also we can make such a simple solar cooker. So 50 rupees to 5,000 rupees, and more concentrated type 15-20,000 also. Lot of designs available, and definitely so you can try some of these designs for your some as a mini project, or in your just for household purpose also. Yeah. Now, as I said, we are slowly moving to concentrating type. And these are the flat plate or the non-concentrated type. Where also we can generate steam, but it's very less pressure. But real, and this the other angle to capture the steam generated from flat plate. But this is the real unit what we use worldwide extensively, parabolic trough collector. And this mainly used for power generation. So we have other two types also. So solar power generation is based on these three units. As far as concentration ratio is concerned, the lowest is this, about 30-40 range, parabolic trough collector. And the next few slides, I'm going to discuss what are the latest techniques we adopted in parabolic trough collector. Dish is in the range of 75 to 100 CR. So, and this can give temperature about 400, and this can give about 200 to 300 degrees Celsius. And more advanced and more complicated version is heliostat. At the end, time permits, that let me run one small video, which really so gives you the complete idea of how the heliostat works. Heliostat, just to realize, it's quite simple. You know that when you focus this mirror properly, so it can redirect the solar radiation or light over the surface. So in this case, what we are doing, let me spend 1 or 2 minutes on this slide itself so that the forthcoming slides should be easy to understand. So this parabolic collector, so this is the reflector, mirror finish. And when it focuses the solar, that's the sun, so here the solar radiation strikes, and based on this surface, this what I call it as the curve, whatever we are maintaining, it's a form of parabola. So it concentrates and it strikes at focal line. We call it as a focal line because it's a line focusing. And here, if it strikes at a point, that's a focal point because it's a paraboloid and this is parabolic. So exactly at that focal line, we are placing receiver. So you can see the bright spot all over the receiver. So now if this area is 1 meter square, entire area, we are talking about the solar radiation falling area, 1 meter square. And if this area is 100 meter square, trough area, so it is 100 by 1. We say concentration ratio 1. But normally in PTC, this parabolic trough collector, it is 30 to 40 range. But here, see here, the entire structure, it is automatic tracking subjected one. So east to west, like that, it tracks every day. And because it is well programmed, so that we should not get any mismatch. Otherwise, what happens, today it may track properly, and tomorrow, if there is little mismatch or a play, then or some kind of drift, then what happens? What is the concentration? Maybe 50% of that it may move out of this without striking the tube. Then there is a real loss. So we should be very cautious in designing the tracking system. Here it's a focal point, so it is subjected to two-way tracking because it's a point based. So east west, north south, like that, you have to continuously track two-way. And this is also, but here in the first two cases, the entire unit is going to track, including receiver. But in this case, receiver is stationary. In this tower itself is receiver, the top part. And all these mirrors or the reflectors we call as heliostats are programmed in such a way that all the way from morning to evening, based on the sun path, all the time it strikes or it redirects the solar radiation over the surface, where we can get 1000 degrees Celsius plus for some metallurgical purpose and all they can use, or a little lower version can be that are used in the power plant. So hope some idea you got about concentrating collectors. So I have, yeah, hardly 1 hour left. So let us discuss more on what are the advances. Yeah, in better way, let me again explain you how is this parabolic trough collector, mainly 5 components. But you must know this is a linear focusing solar concentrator. So this is a trough, parabolic shape. There is reflector we call heat collection element. Heat collection, this is a receiver. So reflector is used to interact with the solar radiation. Then it strikes the or redirects the radiation over the unit, call it as heat collection element. And to support these two items, we need some support structure, and the structure should move with respect to the sun path. So we should have tracking mechanism, and through this tube or receiver, some fluid should flow because we need to extract, remove heat, whatever accumulated in the over the tube by passing some fluid. We call it as HTF, heat transfer fluid. And the same thing in the form of image I have shown here. So this is the real unit trough. You see the bright line, and this over that you can find the black pipe. That is the actual receiver, and but over that we have a glass cover, evacuated glass cover. This entire unit is going to rotate based on sun path. And if we pass, because there are direct type, indirect type steam generation concepts are available. In direct steam generation, if you pass water at some pressurized condition, here it is a that saturated liquid or subcooled liquid, and when it reaches this side, it's going to be a steam, saturated or superheated steam. Or in indirect steam generation concept, we are passing high boiling point heat transfer fluid, so that all the way from entry to exit, it doesn't change its phase. It's in the single liquid phase itself. In a later stage, we have a secondary heat exchanger where it interacts with the water to convert it as a steam. So that is the indirect steam generation concept. So this is about parabolic trough collector. Let me just highlight how that receiver, because this is the real, I can say, the heart of the system. We say this as a evacuated tube receiver. You can see this black coated tube, and over that there is a glass tube. And remember, the same concept is available in this exactly same way, but it is from one side it is open. And why we are evacuating that? Because you know that particularly mechanical background, those have mechanical background, they can see that, or they know when there is evacuation or when there is no medium within the space. So the only chance of heat transfer is radiation, because anyway conduction is already taken out. Convection is also suppressed by removing whatever the trapped air. So that's why, and this is the point, at the end they, using vacuum pump, they suck air entirely from this, because this are all sealed, and see, like this is the end sealed, and whatever the air present in this is totally sucked out using the high rating vacuum pump, and it is sealed. And now some practical problems in earlier days, what they came to know. The one is because this glass having different thermal expansion coefficient than this metal, normal nickel steel tube. So what happens when the solar radiation strikes? The temperature increases, and because of different thermal expansion coefficient, the expansion or contraction rate of these two materials will be different, and that leads to some cracks. And when it cracks, the evacuation gone. So there's a huge heat loss from this receiver to surrounding. That's why they are using bellows. This is metallic bellows, so that this inner unit is coupled to this, so that it can have a differential expansion managed by this bellows. And we also can see a gutter. This is a small metallic unit with surface finish like very much like glass. It is also incorporated in the unit, so that by chance if there is any leakage, if there is a micro crack, we call it as in orthopedics hairline fracture. So some micro crack is there. Then what happens? Because this is highly evacuated, and the surrounding air can enter to a certain extent. So, and if whatever that the quantum of air enters, so definitely the heat loss starts in exponential way. But we may not came to know that unless you sense the temperature, the surface like that. So they keep the small surface, it's some metal piece with some other special chemical coating. When the air enters and comes in contact with this metal surface, it becomes like this whitish. See, this is the in evacuated tube, the barium getter, how they put. In original condition, it's like this, and if there is a crack, it looks like this. This is the direct indication that yes. So there is some crack in the unit. Okay, so this 11 put. Okay, now some advances. See, you should know that when you talk about research, there are mainly two the versions. One is of academic interest, and other one is of public interest. And public interest is the real it matters, because whatever the technology we develop or the whatever the method, whatever, so it reaches to whom it should reach. But it's not very easy to directly grab such research projects unless you have some academic based research projects or ideas. So normally a researcher will start with some academic based projects. Once they get acquainted with the project, they will move to more of public interest based. And sometimes it may happen such that while doing such academic interested projects itself, the outcome may be of public interest. So this is why I highlighted. Let me take the example of nanofluid. So nanofluid, you can find the n number of papers, but there is no the official application of nanofluid in the commercial stage because of its agglomeration and other effects, the kind of even cost also. So that means still it has we need to work on this so that how it can be incorporated in real systems. Because recently I had been to, before this lockdown, I had been to the international workshop on heat exchanger that's organized by ADA, Bengaluru. So there also they present a lot of this aviation related these projects which works on nanofluid. But at the end, when I asked them, have you really incorporated in some of your latest projects, they said, no, it's all that only lab scale and it's for academic interest. And some more in-depth analysis is really required. Otherwise, the Department of Defense, they won't allow them to do that kind of modification in the UNX systems. So, yes, now when we say the heat transfer augmented techniques in parabolic collector, normally I classify it as 3 types. So I think, now I've completed 20 slides. So that is about 25% of the total number. Let me break for 1 or 2 minutes so that you should not think that it's a one-way match. So if you have any doubt, now also you can ask, or if you guys are comfortable, I will continue. So yes, please.
Sir, there are questions.
Yeah.
One question is from Mandar Sumant.
Hmm.
How circular solar collectors for close water, open air, heated humidification and dehumidification process use, and how it is advantageous or not? That is what he is asking.
Can you
How
repeat?
circular
Yeah, circular.
solar collectors for close water, open air (CWOA).
But can he directly, can he talk to me now? Is it possible?
Uh, I do not know, sir, whether he is there or no. 1 minute, let me check. Yes, sir, he is.
Yeah, yeah.
I
So,
request Mr. Mandar Sumant to narrate his question. Sir, if you can hear me, please unmute your mic. He's saying that his audio is not working properly, sir.
okay, because I could not get his question. Please repeat in circular, but the circular
How
itself is,
circular
uh,
solar collectors for close water, open air, heated humidification and dehumidification process used? I think he's asking about the humidification and dehumidification process that the solar collectors with closed water open air system works. I'm not sure,
yeah,
sir.
yeah, because some of that circular solar water heater, I think so it is the vague term because we have normally evacuated tube water heater, plastic water heater. But I can tell one thing, but I don't know to what extent he will understand that. So later also he can just mail me the exact question. I can answer that. So I mean, he is talking about the submerged condenser based design. In such cases, particularly the this condenser is submerged in the fluid or whatever the water or other fluid, and when the hot fluid moves from the solar collector, so when it enters the condenser, because of the rise in temperature of the condenser, so slowly it is going to evaporate the fluid, and in that way, relatively the better the quality, or I can say the content wise, the better quality fluid it rises, and later it can be condensed back and stored separately. So this is what we are applying to the condensation and evaporation process with respect to the solar water heater. And in humidification and dehumidification process, we are normally using solar air heater or solar air dryer. So because by passing, normally we are using the forced circulation based solar dryer, which can be used to heat the particular the component of the within the heat exchanger, and over that if you pass the humid air, so dehumidification can be done. So I think because that's why I wanted to discuss directly with him, hope to a certain extent be understood. Whereas let him ask him to mail me the question, or you can
Sure, sir.
share a number. Any other question?
The same person is asking what parameters should be considered for the circular solar collectors for CWOA air heated humidification and dehumidification process. So he's asking about the parameters.
So here the parameter is at what rate the humidification or dehumidification to be done. So for example, now if I say the air heater, if I use for dehumidification process, so we should have some analytical calculation, because based on the psychrometry chart. So how much heat is required? So for example, now the humidification or dehumidification rate is fixed. And if I say the dehumidification rate is maybe if you consider the air flow rate or the quantity, 10 lpm per second. So to have that the kind of dehumidification process, we should have some energy balance calculation. So how much energy is really required to dehumidify using the psychrometry, the enthalpy difference and all we have to check. And that finally we are linking to the m dot Cp delta T. So that is the water or the air side. So how much, at what temperature the air should enter this dehumidification chamber, and at what flow rate, so that the temperature difference should be fixed. So once we do this some analytical calculation, so based on that, so we have to design the solar that air dryer, and while doing so, we are taking the solar radiation normally, because it varies, right, all the way from morning to evening. We are taking around 600 to 700 watts per meter square as the solar radiation, and over the day we calculate some 5 to 6 hours. And one thing, let me make very clear, since it is solar radiation highly time based, we cannot have the same conversion rate. It differs. Otherwise, we should go for some energy storage device to have the constant conversion rate.
Okay, sir.
Yeah. So, any more questions?
Yes, sir.
Okay.
Mr. Bhanuprakash just asks, is it possible to get the heat from solar energy directly into the kitchen to replace stove?
Yeah. So, uh, I don't want to answer that question time being. At the end, I have few slides, and I also highlighted some of the research topic on that. So, ask him to wait till the end. Or
Sure, sir.
at that moment, I will explain. Yeah.
Sure, sir. I
Any
have
more?
one question, sir.
Yeah. Yeah.
Which solar cooker design would you recommend that would cost below 2000 for domestic use? Any particular design you have in your mind, sir?
So design in the sense when I go back, yeah. So here, this box cooker cost about 1,200 rupees, and sometime you will get in this multi-reflector designs. So
Mm-hmm.
here, so this and the advantage of box cooker is no need to tilt, no need to track, nothing like that. So in proper the sunny place, you have to keep and wait for about hour like that. So if you use this kind, it may come within 2,000 rupees, but this is really efficient. I hope you can see the pointer, right?
Yes, sir.
So, but it cost about 5-6,000, and the other limitation is continuously once in 10-15 minutes you have to track this. So,
Mm-hmm.
but this is non-tracking. This is, it should track this manually. We don't have any motor like that. So if you do like that, so within half an hour, this is not claimed by someone. Even we got it in lab. So this 5 to 6,000, 1,000, and around 2,000 close to that you can have. And in fact, even we can also fabricate if you have sufficient lab facilities. It's nothing great.
Mm-hmm.
Is that okay?
Got it, sir. Got it,
Yeah.
sir. Sir,
So
one more question.
yeah,
Uh,
please.
is there government-based subsidy for this kind of installation?
Yes.
Mr. Vishnu Kamath is asking the question.
Yes, in Bangalore, present I don't know. Some KSDL, I'm not exactly remember. One agency is there, Karnataka Renewable Energy or Cradle, I think Cradle, Karnataka Renewable Energy Agency, like that. So they can just Google. And
Yes, sir.
they are giving, I think, about 30% subsidy, particularly for these cookers and all. So if we buy from them, so yeah, that government subsidy is there. Even we know that when we install solar water heater, so earlier it was mandatory for any new house to get this electrification. So we used to have this one solar water heater, and they are also giving 50 rupees rebate in every month electricity bill. So government is really supporting, but the thing is how we will take up. So that I think Cradle, ask him to
Sure,
check.
sir.
Yeah.
Sir, one more question from my side.
Yeah.
Among the various nanoparticles that are available, or materials, nanomaterials that are available,
Mhm.
which, according to you, could offer greater stability in terms of dispensing in water?
But the study says, as far as cost, stability, and the performance, if all these things, if we, I can say, take up together, so L2O3 is the best.
Okay, sir.
Yeah.
Yes, sir.
Any more?
No, sir. That's it
Ah,
from for
okay.
now.
Okay. Very good. Yeah. Yeah. Yeah, see, yeah, I just started this slide. Now, I said there are three methods to improve the performance, or we call it as heat transfer augmentation. So, first is surface. See, surface based is more of it is physics based. Our role is very limited because here is this surface, this is a reflector surface. So, how to increase its reflectivity? It's more of optics based, and there is a evacuated definitely glass tube. How about the transmissivity of the glass cover, and then absorptivity of this coated tube, and its emissivity? You know that absorptivity should be highest, emissivity should be lowest. So if you have a higher value of emissivity, what happens? Whatever the uh, radiation or the flux you are absorbing, you should hold it within the unit. If emissivity is high, what happens? It simply, if it emits to the surrounding, then there is no question of absorbing the large quantity. So that's why higher absorptivity, lower emissivity coating, we call it as a black chrome coating. So those are all surface based. That is really optics. And fluid based, how we can enhance the performance of the flowing fluid? As you are asking, one of that is the nanofluid. So how we can use nanoparticles like copper or aluminum oxide or even carbon nanotubes. So these are a lot of methods are available and in different concentration level. So if you put it into the fluid or mix it into the say water or other flowing fluid, normally in solar power plant we are using dotherm or terminal VPS heat transfer fluid. If you use mix little quantity of that, yes, it is the truth, and it's I can say the everybody observed heat transfer enhances. But how about its sedimentation effect after some time? So now we are using chemicals, even we are doing ultrasonic process, so as to make it stable for known time, maybe 1 day, 2 days at the max. Over the time, if the fluid is really circulating all the time, then the sedimentation effect can be slightly less. Otherwise, slowly, so it's going to have that effect. That's the biggest challenge, and also the cost. So that's why, as I was telling, in academic part, we are using means the researchers are using, but it's not really come to the market. Like this is the nanofluid based setup like that. So that is the fluid based, and the next one is flow conduit based. That means the fluid is original only, water or other heat transfer fluid, but in the receiver, this in here in this receiver, we are using some inserts that may be wire coil, and the receiver it may have internal fins or it may have twisted tape. But here, all particular this wire coil, which increases the resident time of the fluid. So if the flow length is 1 meter and the fluid is flowing through a plain tube, so say it takes 2 seconds to clear that distance. Instead of that, if you put a wire coil or some obstructions like that, so the resident time, fluid takes slightly more time, and it it is having contact with the larger surface area, because you see, when the fluid flows through such a this kind of mesh, what happens? Every fluid particle has got a good chance to interact with the surface of the receiver, so that heat transfer or the better heat extraction is possible. That is in wire coil. And in twisted tape, what happens? So if you look at this, the pattern, when the fluid, so it's not really flow like the simple pipe flow. So it is subject to the swirling because of this twist over the twist, whatever there in the tape. So every time it swirls, it rotates like your washing machine tumbler. So what happens? The fluid is continuously agitated all the way from entry to exit. So in that way, heat transfer or the recovery is better, and this directly enhances the heat transfer area, that is fins. So with this also, we can increase the heat transfer. And nowadays there are a lot of papers coming on various this inserts, particularly Chinese authors and all. They what not, I can say what not they tried. See some funny shapes. I'm not blaming any researcher, because ultimately the aim is to insert, whether it is practically possible, whether it's easy to fabricate, that is the secondary question. Because CFD we have, so simply they try with different designs, and whichever gives the best performance, they claim, yeah, this is the best. So that's all about a lot of this inserts. Now let us come to the testing type. We know that outdoor, because it's the solar, and whatever you simulate in the lab, we cannot say it is 100% replicating solar, because outdoor solar energy is outdoor solar energy itself. So no substitute for that. But what happens? We have some limitations, and that's why every time we cannot go for outdoor testing. So there are many methods available, so that we can, to the possible extent, we can replicate, we can simulate the solar radiation in indoor testing. So here, when we come to indoor testing, there are two types. The testing of concentrating and non-concentrating type of solar system matters a lot, because non-concentrating type, simply we need halogen bulbs that I'll show in sometime later. So even you can fabricate that if you are really testing anything, maybe all non-concentrating system. So you have to simply paste maybe 100 watt, 500 watt halogen bulbs over a common reflector of say a rectangular size with many holders, and you connect through regulator to the power supply, and you just regulate that. And if you have a simple solar flux meter, it shows 500 watts per meter square, 800 watts per meter square, like that you can simulate. But when you move to the concentrating collector, so this halogen multi-bulb phenomena won't work. And if you try to use like that, you will get multiple reflections from the trough. For that, the single light source is required. Normally, they call it as a xenon bulb. So, and it is too costly. Even we are not ventured into that yet. But earlier, a few years back, I saw this kind of arrangement in CPRI Bengaluru for testing some of the solar products. So, why I want to highlight that, if you want to test solar water heater, cooker, all those things, box cooker, so during off sunshine hours, you can use a simple multi-bulb simulator. Otherwise, single point source, xenon. It is a mini or micro sun in the lab. So that concept is used. And recently we found out this resistance heating concept, particularly for concentrating collector. So that I will discuss after a few minutes. So otherwise, this resistance heating is a very old concept. You simply wind nichrome wire, other material wire over that, and just supply it to either step down or normal heating procedure. So the tube gets heated. Provided that you should have electrical insulation. Yeah, any doubt? Because I feel it's in between. It's better to ask.
No particular questions in the query, sir.
Okay, right. Yeah. Now, first we'll take up outdoor test rig. So this is the system what we have in the lab. Even though, as I said, the parabolic trough collectors are meant for only single axis tracking, but we have the system which is subjected to two axis tracking. You can see the LDR unit here, which senses the sun, and like a lotus, it tracks the sun for 6 hours. And this is the reflector, and this is the heat collection element. And this entire unit is having this subjected to or linked to two actuators. So it based on the, see, it's nicely programmed unit, and it tracks the sun. And we have all control panel and this tank, pump, everything is mounted here. So we do some tests in this, and the twisted tape we tried in this, and what is the announcement. So that also we published. This is outdoor test rig, and these are how the schematic of that. It may not be very clear to you now. So yeah, so this is how the twisted tape looks, and it is the intensity of the heat recovery process is based on twist ratio. So we call twist ratio as H by D. You can compare H of these three. Okay, so if 5.2 means it is this twist alternate, this 180-degree turn. This length is 5 times the diameter, or diameter in the sense because we are putting it into the pipe. So normally pipe ID is its dia. So like this, if you go for more and more this higher value, the effect is poor. So that is quite common. Yes, some instruments, very normal instruments to be used to measure, because this receiver surface temperature, we got it from thermocouple itself. Then glass temperature, because we must know how much amount of heat is lost from glass to surface, the surrounding. That is infrared thermometer, that's fluke. Then when the fluid flows through the tube, see this one here, entry and exit, there is a pressure loss. How to measure that? We have a pressure transducer, and this can be connected to even the digital output, 4 to 20 milliamps. That directly can be taken by the data logger. No need to monitor this, so automatically it records. So flow meter, simple turbine type, then anemometer. So these all are simple gadgets. 4,000-5,000 are available, because these are all some of the normal projects what we are doing for our MTech and BTech students. So that why I am highlighting. So I'm not saying we are the great people in this field of research, and I'm also not telling that who are participated at the other end. So it is, we should have that research, that concept, or that kind of the thinking must be there in us. Then even with the simple products or simple design, we can start research. To be frank, at the end I will show you the our lab facilities. In fact, when we were at 2013, we were nothing, because at the time our kernel program started. So hardly we had this one. Yeah, this was there, and this. These 2, 3 items we had. But now at 2020, yeah, 6 to 7 years, now we have all good equipments, Of course, I should thank our university also, they are generous in providing such facility. And recently we got DST fund also. And students also, they are with their own interest, they ask for any projects they involve during so off hours also like this. So this is not with only with the money, it won't happen. So that kind of tendency we should have at the student level as well as the faculty level. Yeah, so these are, see now the how to measure the radiation. We all say that it is efficient, but unless we know how much input it is taken, so we need to have a parameter just to measure solar radiation, and all these parameters, the pen and paper concept gone. So now we are more worried about the transient analysis every second, every once in 5 seconds, 10 seconds. If you want to gather some 10, 20, 30, 50 data, so you attached, for example, taking a little more time. Yeah. See here, we attached 16 thermocouples. And all these things, every 5 second, 10 second, if I want to get the data, we cannot simply rely on that knob system with the digital temperature indicator. We should have a good data acquisition system, that is Keysight or Agilent earlier. So all the output from our transducer, if you connect to this, hope many of are already using. I don't think that. So this is a known thing itself why he is telling. But those are not used. If one or two are also there in the in the list of participants, so it is worth to tell. So you can capture the data at the rate of millisecond. Just remember how the best transient analysis we can have. And yeah, and it's obvious when you use twisted tape, the performance increases, enhances the instantaneous efficiency because this is a different radiation level. That's why you can see this up and down. But the lowermost is plain tube, uppermost is the having the less twist ratio, twisted tape. But this is what instantaneous efficiency. But remember, those are particular to the mechanical this participants I'm telling, and also known to you. Only instantaneous or thermal efficiency is not our target when you introduce something, including nanofluid. So actually, we should have three analysis: thermal analysis, thermohydraulic analysis, also cost analysis. And when you go to cost analysis and apply to nanofluid, you are gone. Or the payback period may be so many years. But those three analysis holds good quite nicely for this kind of inserts. Because for example, this insert, each piece 2 meter length, will cost 800 to 1000 rupees. And we got some wire, this matrix, some designs from Pune, that Concept Engineering International. When we are just browsing and we came to know that they are manufacturing, we just approached them. And see, they were happy to give their products free of cost, even they were the transportation cost, and they supplied a year back. And we used that, we incorporated in our indoor system. We could get a good result. We published a paper. Only thing is, in acknowledgement, we put their name. That's all. So it's like a give and take policy. They are also happy, we are also happy. So like this, unless you just interact or communicate with some industry, because people they are also, because for them this wire matrix don't really cost much, but they want the returns in different way, not the price wise. This is fame wise they want. Yeah, but what I wanted to tell now, whatever the increment you are getting here, this is not the real performance. But for this increment, you lost something. You lost something is pumping power. Because when you insert something, so pumping power increases. I mean to say the pressure drop increases. So For example, now when you pass simple fluid and the pressure drop is 20 Pascal, and when you insert, put some insert, it may be 200 Pascal. Tenfold increase in pressure. Pressure is not a free gift because you are pumping. You are pumping means it's not a God gift. So you have to pay from pocket to power it. So in that case, the term thermohydraulic efficiency matters. So how much you gain from the input, but to gain this much, how much you spend. That is the pumping power. If you use this equation, and sometimes we call it also PEC, performance enhancement criteria, PEC 1, PEC 2, PEC 3, if you look at some articles. So if you use this formula and calculate again the performance, there also, if this is at the top, then your claim is valid. So sometime what happens, for some design, the pumping power may, or this value may come down compared to plane. So in such operating condition, plane this receiver is better than this enhanced thing. Okay, so how much time I have now? Yeah. So it's already 12:30. Yeah, so this is the efficiency improved. And yes, now those all are about outdoor based. Now indoor, so we tried with this software called Soltrace. Even you can also check. It is open source software available from NREL, which directly gives you the how the solar radiation pattern over the receiver of the parabolic trough collector. So that is in this form, with bottommost region is subjected to highest, and here you can find a dip. This is because of shading effect, because see here this tube is going to shade the surface of the reflector, so you get this kind of shape. And at the top, the radiation is minimum because here it is all direct radiation. So what we can do, this analysis if you do in Soltrace, and if over the surface if you can have many segments, and if you find out, see here it is 450 wattage is actually falling, but at the top it is direct 13.7. You see the ratio. So this is what we call it as a local concentration ratio. So this also, yeah, this is using their wire matrix, what we published in renewable energy recently. So this kind of segment we made, and what accordingly we applied that differential wattage in the test tray. This is the MTech project. So in this test tray, over the receiver, that simulated radiation what we got from Soltrace we applied, because we have a lot of strips here like this. The strips are like this. So this strip we are supplying more heating. So it is bit less, then still less, and minimum here like that. So we need to have the real simulation of the solar radiation, and this is all data acquisition system, power analyzer, and how to change the flow rate. So instead of using bypass valve window, simply we can change the frequency of the power, that is variable frequency drive. This unit if you attach to the pump, so you can just whatever the flow rate you want, you can adjust the flow meter. This is the transformer. There are four for different power supply. So this also we tried with various radiation. This data we took from meteorological department, and if you put it in Soltrace, that directly gives the solar radiation spectrum, and this how the variation in the temperature of the receiver and the performance also we published. Yes. Now coming to, see now one point that I highlighted is pumping power in parabolic trough collector. To pump power, we need power. The fluid, we need power. But nowadays, people are researchers are looking at the natural circulation based system, where you can use the thermosiphon effect for transfer of this circulation of heat transfer fluid. So there is no pump required for that. What shall do? Shall I continue or to break for a while for taking your questions, because I hardly left with another 15-20 minutes. And I not
As of now, yes, sir.
no queries.
I'm sorry. No, sir. No queries are there in the chat box.
Okay.
So, could you
Yeah,
please continue, sir?
okay, okay. Because we took our thermal management of PV. This is a natural circulation based. So this the research gap we identified quite long. It's about 1.5 years back by doing the systematic review, and we came to know that this is the topic of the day. And as one of the research projects, so the similar the setup, the fabrication is going on, because this is we are subjecting it to the high pressure. It's a massive structure, so this only structure cost 75,000. Yes. Now the other advance in the solar collector is beam down concept. Now the normal this paraboloid collector, you know that this is a dish, the paraboloid dish, and here there is a receiver and solar strike like this. It's a point focusing, but it should be mounted at certain height, and after that this receiver is at again at certain height. And if we want to have some natural circulation system, then you know that this is all happening because of buoyancy. That's a thermal buoyant force. So what happens? It is the gradient matters, the height matters. Instead of having the natural circulation system with respect to this point, then this is going to be heater and your cooler will be somewhere here, still at more height. So with proper reflecting mechanism, it can be, that's what we know as beam down and light pipe concept. So this solar concept radiation, the target is to bring down to the ground or so uh, underground level, and there if you locate some natural circulation system, so natural circulation system heater part will be all the way from this point to underground level. So at the normal height itself over the ground, we can have that system for any maybe power generation, solar indoor cooking like that. So this is a concept proposed by Dr. P.K. Vijayan, the eminent scientist in DRC. Now he retired and recently joined IIT Jammu, and he is helping us in many of our projects. And just for your information, if you just Google any natural circulation loop based paper, so one or the other way you will find his name, and his name is Dr. P.K. Vijayan. Okay, so just in between, let me have just divert from solar energy to the nuclear part, because this is a one more ongoing project. You know that in this nuclear accident in Japan, that Fukushima, where because of this earthquake, there is a tsunami issue. So their power plant, so they forced to shut down, and also this nuclear reaction. You know that it's not like our conventional thermal plant or hydel plant. So suddenly we cannot shut off or shut down the plant. So when you yeah, any question?
Ma'am, you are not audible.
Uh, shall we take it at the end, because let me cover.
Yes, sure.
Let them note down the slide number. Yeah. So there even they could shut down the plant. I think better to mute.
Yes, sir. Could someone please mute Sumati K?
Yes, I will do.
Okay. So now what happened there? They could manage the shutdown process, but because of nuclear reaction, that process, that radiation process will continue for a few days. And that is, we call it as a decay heat removal. But because of the failure of their post system, they could not control that. And finally, so that disaster happened. So post Fukushima incident, now the nuclear scientists are looking at the completely passive system to remove the decay heat. So that's why the BRC, they gave this problem to us, and even say this is what I was highlighting, that scientist. So he is also involved in this project. So here our ultimate aim is, if this is, if we treat it as the source for decay heat, so how best we can discharge it to the surrounding, because it is in it's a few meters huge loop. So that's what we have done, coupled loop here. First we try, we have this first loop, that is water, then one more the loop, again water, and the last part is the air heat exchanger based loop. So whatever heat generated, ultimately it should be discharged to the surrounding, and here nowhere we are using pump. Okay, just for testing we are using thermostatic bath, otherwise everything is by gravity. So this is what the way to demonstrate the decay removal using the passive method. This we could publish in Interest Journal of Heat and Mass Transfer. Yeah. So this, with this, I'm going to wind up the thermal part. So let me quickly start photovoltaic. Then we'll take up the queries. Yeah, photovoltaic. I don't want to get into detail. It's working and all. It's all known to us. So it's a photoelectric effect. Normally, the silicon is the base material, and we have a single, that is, we call it as monocrystalline, multicrystalline. But normally nowadays we are using multicrystalline because of its cost. So the efficiency is slightly less. Cost is, and fabrication or the manufacturing process is a bit cheaper. So now there are different type of mountings with respect to PV. You can have roof mounting, then stand mounting, land mounting. So a lot of applications are also there, and most of them you know. Lantern. So instead of showing this slide, let me take one by one. Solar lantern, PV based, then solar home light, street lights, then grid connected system. Even we have a demo system in our lab. So how we can see, this is a very nice element. Even this both state government is having that scheme. So you generate power and you can sell it to the grid and earn. And this is also subsidized. So if you contact this MESCOM, HESCOM like that, so you'll get more details. Then for water pumping, also we are using photovoltaic modules, and power plant. This is a 6 megawatt power plant in Gujarat. And in satellite, this is one and the only option and the best option available to power. And even in our college also we have this solar mobile club, solar car or solar automobiles. Yes. Now coming to the real theme of this lecture is, we know that now, or if you just touch the photovoltaic front surface, that's a glass surface, you will find very hot, at least for 50 degree like that. But but at the same time, if you touch the evacuated tube water heater outer surface, it is almost same temperature as surrounding, because that means heat is not lost. But here, actually, the purpose is not to gather thermal heat; it should convert light to energy. But what happens during that process, because of this wavelength limitation, so some percentage of, or the range of light absorbed as heat. So the panel surface, front or rear surface, is really, it is hot. And what happens at when the panel is subjected, see, this is the normal IVPV characteristics, and the panel temperature is increasing. So current increases, voltage decreases, but the drop in voltage is substantial than rise in current. That ultimately gives you less power when the temperature is high, operating temperature is high. So this uh, the change in power with temperature is covered. And normally they claim this is the rate of deterioration with efficiency with respect to temperature. So now, being a mechanical engineer or the thermal engineer, so what we can do? That's what we call it as a thermal management. So we have two systems, active and passive. So active system, air cooled and water cooled, because we use blower or pump. Passive, it is natural system. So this is air cooled. We can blow air, cool it, water. So it can be pumped or even recirculation type, thermosiphon. Even you can attach fins to the back surface, rear surface, so that it can be released, or you can store it with PCM, piston material, so that it absorbs the heat from the panel. Even in canal also, there are, I think this is an example from Gujarat, so where it is fitted canal. So because of this relatively cold air, so it cools the panel. So this is, yeah. Now, if you space in material, at a fixed temperature it melts. So now this is one example I took. Where without any cooling, the temperature went up 86 degrees, which gave 13% performance. Whereas if you use PCM, and the temperature is 55 instead of 86, and efficiency increased by 2.3%. So this is the change. Many designs are available. So aluminum absorber plate to the back, then you can put copper tubes and pass water. Even you put copper tubes and fill it with PCM so as to cool the surface. Ultimately, our aim is to cool the panel surface. And here, some studies shows that if you use water cooling system, temperature 38.5% you can cut down. And if you use that water cooling system with piston material, so 50% cut down in temperature is possible. Even in PCM, because that piston material, only paraffin wax and other components, are having very less thermal conductivity. So as to have better heat diffusion, they even tried with nano particles, and because it increases the thermal conductivity. See, I quoted 0.25 to 15 is the change. And see, PV with PCM, it temperature decreased from 75 to 61. And if you use PCM with nano, again, further drop of 4 degrees is possible. So even metal matrix, metal chips with PCM also, like choco chips in hide and seek, what you can see, the similar kind of concept they tried. So for better diffusion, it also gives better result. When we tried this, the flat water duct over this photovoltaic panel will come. So for uniform cooling, so this is surface contact. This is a line contact type water cooling. So this is a long back we did this testing, only photovoltaic. With this is the I said no non-concentrating time solar stimulator with halogen bulbs and regulator. So this and with water cooling duct, how the performance changes we tried. This is a schematic of that. Anyway, so at the end I will share this PPT so that you can thoroughly check, and if any queries also you can write to me. So temperature, definitely the TWOC means without cooling and with cooling. So with cooling you see the temperature. So everywhere it is 34 to 38, whereas with radiation changes you see the without cooling final temperature. It went up to 66, and that also matters in PV efficiency. We got the improvement. Even last year we tried with this phase change material with metal matrix. See, there are 3 units here. One only this tube with PCM, one tube with PCM and this kind of metal this structure. This we tried. It's filled with PCM and we tested outdoor. So that time also we were using the old concept, rheostat and multimeter. But recently we got PV analyzer. But here you see this, the PCM level, the melt level is less because it is uniformly distributing heat to the entire system because of this aluminum matrix presented. But this is without matrix, so it melts faster. So, and when after some time both melts, and this is the completely melted PCM, because rear portion we put glass, that's why you could see this kind of the flow. And this we could publish and see this is the result with and without metal matrix, how the performance varies. And recently, some passive system also we tried. This is a solar air heater ultimately. So this is an absorber plate, then solar is hot over that. It takes heat, that it sucks air and flows over the this region. But over its path, if you put panel, so it cools the panel. It's this air heater and panel. This we call it as a combi system. It's a kind of give and take policy. So air heater wants some preheating. So that is done by panel, and panel requires flow of air. That is given by the this air heater. So this is also a nice bit of project we did, and we could publish. So in this one, Relay Journal. Yes. Now, okay. Any doubt? So I have 2-3 slides, and if time permits, 1 or 2 videos. Otherwise, I will wind up. So any doubt so far?
Sir, I have a question with regard to slide number 69. So is it your work, sir?
It's no. These are some from literature I am putting.
Okay, then I just wanted to ask what will be the effect of thermal cycling on nanoparticle? Once again, I was thinking in the line of agglomeration, and
Yeah,
that would
yeah.
bring, yeah,
But I
that would
think
cause.
definitely you'll get some information because, to be frank, we are not trying the nanoparticles because
Okay,
some other group they are trying, but in my lab, no, it is just for the information I am sharing.
okay, sir, fine.
Any other doubt?
Mm, no, sir.
Okay,
Oh,
so
one more thing, sir. The phase change material that you have used, which is it, sir?
that is RC, yeah, somewhere RC 44, I think. So somewhere I mentioned, I don't know.
The
Yeah,
chemical composition or anything?
so the composite, because we have one supplier from Gujarat, and
Okay.
he can provide. See, he put it as the brand as RC, and where based on our whatever the melting temperature we mentioned, so they change the compound and accordingly they give. So now this is RC 44. So
Mm-hmm.
it melts between 43 and 47, that range. So that way you will get,
Probably some waxy compound, I think.
yes, exactly.
Okay,
Uh,
thank you.
yeah. So last two important slides. So these are some online projects which includes PhD and MTech. So this is what I was telling about the decay heat removal in using coupled natural circulation loop. And we want to apply this natural circulation because solar radiation, solar energy is the nature gift. At the same time, natural circulation is also nature gift. So why can't we combine these two and make the product as the best? So that's the target of any good researcher. So in that path, so we are trying this natural circulation loop connected to parabolic trough collector, and this is yeah, this project starts this month about the use of solar indoor cooking concept using again natural circulation. Then in NCL we can enhance the flow rate of a fluid within the loop. How we can enhance by using binary fluid, using different boiling point, and by injecting using bubble injection pump, how we can enhance the performance. Even the inventory volume, how it matters the heat transfer rate is based on void fraction analysis. This also going to happen. And this is one mini project, thermoelectric generator. So at the back of PV module, if you connect thermoelectric generator, so that is also generating power and also extract heat from the PV panel, and PV panel also generates heat. And thus we are trying to compare heat pipe, because heat pipe is a very old version, and we want to substitute by thermostat and heat transport device as far as long distance heat transfer. So yes, these are the better participant can read this. These are some research areas what I mentioned. So those are still identifying some topic, or it's not only for PhD. Any maybe tech level or any as a lab project, you can take little part. So see about the solar cooking. You said someone is asking question. So here somewhere I mentioned. What is that? Yes. Design analysis. See, improved induction cooktop powered by PV module. I think some Puttaraju. So if you Google that, you may get his details. I think he's the first person who tried a PV panel connected to this the conventional induction cooktop system. And I'm not very have in-depth information about that, because it's all are to do with mechanical stuff. But some problem he might have faced. This is also the best way. But the panel size and all, we should be careful, because this is normally we are operating at 1000 watts like that. So, and from atmosphere also water can be generated, that is pure water itself. So even the products are available, but still you can try how best you can enhance. And concept of solar room. So we have water heater at present. So we should have some hybrid system which can fulfill our cooking, heating, bathing purpose, everything, heating, cooking, even this room cooling, all should be done with one system, hybrid unit, like this HP, this all-in-one kind of system is coming, scan, print, like that. So that also we can think of. So some other, and PV module, this people, company people, they don't really want all this thermal management. This is the additional stuff. But they are trying with some the glass coating over that, so that dust should not stick to the surface, even the water droplets. So in some leaf, you can see when the water droplet falls, it simply escapes. Some coating is there. So that kind of coating for water accumulation as well as anti-dust, they are thinking.
Super hydrophobicity.
Yeah. So these are some projects, and I don't know now there's any time to show my videos. If still you are comfortable, I can play one or two. Otherwise, let us stop. If you have any queries, let me take it.
Sure, sir. We can go ahead with your videos. I hope Mr. Bhanuprakash's point is also made over there. He had asked a question regarding, is it possible to get the heat from solar energy directly into the kitchen to replace
Kitchen,
stove?
yes. There is one concept called this one, Scaffler model, but it's not really total into the kitchen, but the one side of the kitchen wall, he made some provision, and there it strikes. And till date, there is no proven technology to have the solar indoor cooking. That's why now we are trying one project on that, and that too for high temperature. So it is not just to cook rice or just heat up some curry, not like that. It should frying temperature 250 plus. So that is the target. That too solar energy and round the clock. So this is the
Wonderful.
yeah. So that is the target. Even many scientists, they are proposing. Even the government also want that kind of community cooker. Yeah. Any queries?
That's it, sir. There are no questions posted on the chat box. I think we can move on to your videos, sir.
Okay. Video. Hmm. Visible?
Yes, sir, it is.
But in between some of the, yeah, sometime I will skip because it takes 15 minutes.
Sure, sir. Sure, sir.
These are some systems what you have in the lab. Wind energy emulator. So wind turbine. And to simulate the solar radiation in a PV over PV panel, the training and research system. And this is what I told, PV combi system. It's a BTech project. It's a PV grid side demonstration unit. The PV panel is rooftop. And this is phase change material based thermal energy storage. So you have fatty acid based and paraffin wax based this PCM here, having different melting point. We are finding charging, discharging, storing, and cumulative efficiency of the PCM based heat exchanger. And this is a solar flatlet water heater simulated version. It's a hot and cold water tank, and this is a small solar flatlet water heater. And this is a simulator, and all parameters we are regulating. So this radiation level can be changed. And this is what I said, sole trace based parabolic trough collector receiver. So these are the transformer I was talking about to supply differential heating. This is the MTech project. And the dedicated high-end workstation we have in the lab, or computational facility, apart from our normal CAD lab. And these are simple outdoor systems, parabolic solar concentrator. This is paraboloid solar cooker, box cooker. This is solar still. This is outdoor PTC unit, 2-axis tracking. And evacuated tube collector. This is flat plate solar water heater. Solar air dryer with this chimney concept, and this is a chamber itself for drying fruits or vegetables. This is we have a separate system for calibration of flow meters. many type of meter. This is orifice flow meter. Here we have. This is turbine type flow meter. Orifice flow meter is differential pressure type. That is Honeywell. So this is a setup we fabricated in lab, and only these flow meters we procured. And this is turbine type flow meter. And here is the ultrasonic flow meter. Yeah, that is also Honeywell. Okay, and these all are some PhD projects going on, and publications out of the lab work. And this will skip.
So this is the horizontal meter, which is controlled by a
Okay, 1 or 2 minutes, then let me skip. This is a BRC defined project.
Set power is of about 175 watt. So this consists of the heater section that is made of nitrile wire of 1 mm diameter. As we move to
So we have a data acquisition system. Then
at this point and the output of 15 kg
this is a thermostatic bar to supply fluid at temperature ranges from -40 to +200 degrees Celsius.
whereas the measuring unit is installed at the inlet of the
And okay, this all my students.
of the DPH section.
Okay. These are some high-end or low-end equipments what you have in the lab to cater the need of research or student projects. We have thermal imager, hot wire anemometer, turbine as well as that hot wire type, PV solar module analyzer, pressure transmitter calibrator Yokogawa. This is thermostatic bar system, and system, thermocouple bead making machine. Yeah, so hope is that enough? If time permits, I
Yes, sir.
have one more heliostat video, maybe another 5 minutes. It's up to you.
Sure, sir. Sure,
Okay.
sir. Sure, sir.
So anyway, now my lecture is over. So this is solar concept. We just say the area where heliostat is located. See, amazing. This is the receiver. These are heliostats. All are independently this program. So these are the mirrors to access tracking. So all the time it strikes. See here, bright region. This one prototype they have. So this is a parabolic dish, in fact. See how you can concentrate and burn. See, this is the same concept, but here this is stationary. This part is moving. And that's power generation mechanism. And if you don't mind, one last small clip That is Dr. L.K. Sripati was my internal guide during the doctoral program. It is nothing about research, but how you can accommodate solar products in your daily life. It's a discovery document. Hope it is irrespective of your discipline you can think of. Since you are not audible to this video,
I am interested in living eco-friendly.
We can hear, sir.
you can hear.
Yes, sir.
Live
Oh,
happily
nice.
without creating any pollution to the environment.
Part of that means talking to the women from outlying villages. They're the ones who run the homes, and homes are where the energy is used. Dr. Sripati heads home after a hard day's teaching. Time for a nice cup of tea. The kitchen is the heart of most households, and it's where most energy is expended too. Dr. Sripati's uses biogas, sourced from kitchen waste. It doesn't stop with the tea. The family doesn't need to spend that much time cooking because it's been done for them. The parabolic reflector catches the sun's rays for the day, concentrating the heat onto a pan full of rice. And a mini greenhouse traps enough heat to cook up some dal. By the time the family gets home in the evening, it's all cooked, nice and slowly, with zero effort. In fact, from top to bottom, Dr. Sripati's house is designed to make as little use of outside energy as possible. So the sun also provides all the electricity. Solar panels fill the batteries by midday, and it heats up the hot water too.
For bathing, it is 100%. We don't use any other source for heating water for bathing purposes.
You can hear his voice?
Yes, sir.
Then fine.
With the Indian sun being so hot, the house has been designed to keep the family cool. A garden of tall plants blocks out the sun. Even the way the walls are built has been thought through.
This wall is made by a special method called a rat trap design. Two bricks are kept, one like this, and alternatively, there will be two layers like this. So in between, you will have a gap.
The air pockets keep the inside of the house cooler, and it has the advantage of being cheaper as it uses fewer bricks. Wind traps outside the windows direct the prevailing wind into the house to keep the air flowing. The large, high vents allow the warm air to escape. Hollow tiles in all the ceilings act as room insulators, keeping out heat as well. In the roof, there's a so-called solar chimney. It sucks out all the hot air in the house. Together, all the measures mean the house is around 5 degrees cooler than the neighbors. Water's a problem in this dry area. It's trucked in and you have to collect it, which means using energy. Not very green. Dr. Sripati has found a way around this too. There's a huge rainwater collection tank, fitting 20,000 litres. A giant filter cleans the water.
It comes here and it enters the first compartment. Here, gravel is provided. Then next chamber contains charcoal, and it gets filtered through these two chambers and goes to the third chamber, and from there it enters the main tank.
Dr. Sripati has had the water tested after leaving it in the tank for a year, with a dash of insect-repelling neem oil floating on the surface. The water remains clean and pure. Dr. Sripati has persuaded his own.
Yeah, so that's it from my side.
Okay, sir. That was very informative, and we are very thankful to you.
But
Sure,
I'm
yes, sir,
sorry,
sorry.
so I took about 30-40 minutes, yeah, about 20-30 minutes extra because to wind up the complete session. Yeah, please continue.
No worries, sir. It was very, very informative and knowledge giving, especially your distinction between the non-concentrating and the concentrating type of solar device, as well as the cooker, and most importantly, your own research work, which was very, very exciting to see what was going on and what are the new things that you are trying to develop. So, on behalf of the organizing institute, that is Mangalore Institute of Technology and Engineering, Moodabidri, I sincerely thank you, sir, for your time as well as for sharing your knowledge.
Yeah, welcome. This PPT I will share you to Dr. Rajshekar shortly.
Sure,
And
sir.
you can pass it to participants.
Yes, sir.
Okay.
We'll do it.
Yeah. That's all, no?
Yes,
Yes,
sir.
sir.
That's all.
Thank
Thank you very much, sir.
Yeah, okay. Welcome. Right.
So, participants are reminded that our next session, that is session 3, will begin at 2:30, and link for the same has been sent to you through email. Please join in at 2:30. Thank you.